This video is an explanation of why different substances are solid at different temperatures, and also conversely why at the same temperature different substances can be solid, liquid or gas. So I'm using a PhET animation for this. If you want to play with that yourself, you can go to the link at the top left. Now what I'm going to do is start with a temperature known as absolute zero. So on screen we have a solid made of particles which are in fixed positions. So because they're in fixed positions, that means it is a solid, so it will hold its shape and it cannot be compressed. Now if I increase the temperature, so I go from 0 Kelvin all the way up to about 79, we find that those particles are still in fixed positions. They are moving now, so I've increased the thermal energy store, and each particle has now gained some kinetic energy. They're able to vibrate, they're able to move around fixed positions, but they are not yet able to move past each other. So the question is, why is this remaining a solid? The answer is that there are forces of attraction between adjacent particles. That means particles next to one another. You could imagine this like magnets perhaps, or any other idea that you have in your head that helps you understand different objects that are attracted to one another. So if we imagine that these are pulling together, there is a force that when the particles are close to one another, it holds them in position. Imagine what would happen if that force was smaller, if we reduced that force of attraction. So on the simulation I've chosen adjustable attraction here. I've currently got it as strong. Now if I reduce the force of attraction between these different particles, all of a sudden the particles are able to spread apart. The substance has now become a gas. Now that means the reason that we have substances, some which are solid, some which are liquid and some which are gas, all at the same temperature, is because of this force of attraction between the adjacent particles, between the adjacent molecules. So we can have a quick look at some of the different types. We can have a look at neon. We can see quite clearly that at 6 Kelvin it's a solid. As I increase the temperature, there we go, once we get to about 27 Kelvin, they start being able to move past each other. So increase it a little more, and at this point we pretty much have a liquid. Some of them are still remaining in similar positions, but most of them are able to move past one another. If we compare that to argon, we'll cool that down as well. So at 6 Kelvin, we clearly have a solid. As we increase the temperature, we're up to 47 Kelvin, but it is still a solid. That tells us that the force of attraction between the atoms of argon is greater than the force of attraction between the atoms of neon.